sensor or circuit may cause the engine to run rough and use excessive amounts of fuel. This is why it's important to understand the operation and testing procedures of these sensors. In this module, we'll be covering the barometric pressure sensor. We'll check out the signal performance and signal erratic DTCs, and the processes needed to rectify them. The baro sensor is a component used in conjunction with a mass airflow meter or manifold absolute pressure sensor. This sensor provides the engine control module detailed altitude and atmospheric pressure data for a more precise fuel delivery. So, how does it work? The baro sensor uses a strain gauge pressure detection method. A piezo-resistive element alters its resistance value as stress is applied. This element is attached to the diaphragm of the pressure sensor. The piezo element uses a Wheatstone bridge and amplifier circuit for a usable signal output. For more information on the operation of these devices, please watch our video on piezo-resistive sensors. These are 3-wire sensors, supplied with a high and low reference voltage. It then generates a signal based on atmospheric pressure. The sensor's purpose is to continuously monitor the atmospheric pressure, so the ECM can optimize fuel delivery at all altitudes. The higher the altitude, the thinner the air, so adjustments need to be made to protect the engine from excessively rich mixtures at these heights. The MAF or MAP sensor alone can't sense the increase or decrease in altitude. Therefore, a baro sensor is used. Like all other pressure sensors, a fault in the baro circuit will set codes in the ECM. Looking at the trouble code table, we can see that voltage high, low, excess resistance, and signal performance-based codes may be set. But if any other fault codes should set, such as ones relating to the intake air temp, airflow meter, or manifold pressure sensor, they should be addressed first. Let's go through the steps needed to successfully diagnose a barometric pressure circuit fault. We may need to remove the sensor and inspect for contaminants or blockages. Ensure the sensor isn't damaged in any way. If this is okay, we can now test the integrity of the circuit and sensor. With a scan tool, check the desired and actual baro readings and ensure they are identical. This is a correct value at sea level. If fitted, confirm the MAP and baro sensor values are the same with the ignition on. Start the engine and the MAP sensor values should reduce as it's now under vacuum. It's great practice to confirm the readings with an altitude versus barometric pressure table. Signal erratic and performance codes typically set because the signal data from the sensor does not follow a predefined pattern set by the ECM. The ECM would expect to see barometric pressures rise and fall in a linear fashion. If the signal from the sensor fell outside these parameters for a predetermined time, the ECM would log a performance or erratic code. This type of fault may be caused by issues within the sensor, harness, or ECM itself. This vehicle has a baro sensor designed as part of the multifunction intake air sensor. Other OEMs may choose to fit theirs in different locations, but their tests are identical. With the ignition off, disconnect the multifunction intake air sensor. With the ignition back on and the meter set to volts, place the black test lead on the low reference terminal in the harness connector and the red on the high reference terminal. Between 4.8 and 5.2 volts should be displayed. Move the black lead from the low reference terminal to the signal terminal. 5 volts should be seen here. If the correct voltage was present during each test, we have proved the circuit's integrity, leaving the baro sensor as the cause of the fault. Signal erratic and performance codes will only be set in the high and low reference circuits if the fault is intermittent. Be sure to follow all procedures for checking this type of fault. With the ignition off, disconnect the baro sensor connector. Place the black lead on a known ground and the red to the high reference terminal. Turn the ignition back on. Between 4.8 and 5.2 volts should be displayed. If no voltage is seen, this might indicate an open within the circuit. Move the red lead to the ECM and back probe the baro high reference terminal. If voltage is now seen, this confirms an open in the harness. If voltage is still not seen, turn the ignition off and disconnect the ECM harness connector. Check for terminal tension and corrosion. If the tension is okay and no corrosion is seen, then the open must be within the ECM. With an open ruled out and the meter displaying less than 5 volts, there may be excess resistance in the circuit. Move the red lead to the ECM and back probe the baro high reference terminal. If the correct voltage is now seen, this confirms excess resistance in the circuit. But if the correct voltage still wasn't seen, disconnect the ECM harness connector and check for terminal tension and corrosion. With no evidence of corrosion or poor terminal tension, the excess resistance must be in the ECM. Connect the red meter lead to battery positive and the black to the low reference terminal in the baro sensor harness connector. With the ignition on, the meter should display battery voltage. If there is no meter reading, there may be an open within the circuit. Move the black lead and back probe the baro sensor low reference terminal at the ECM. If the meter now displays battery voltage, this confirms an open within the harness. However, if voltage still isn't seen, the open may be in the connector or the ECM. Turn the ignition off and disconnect the ECM connector and inspect for corrosion and adequate terminal tension. If no fault is found, the open must be in the ECM. With an open ruled out and a lower than expected meter reading when testing at the baro harness connector, there may be excess resistance in the low reference circuit. With the ignition on, move the black meter lead to the ECM and back probe the low reference terminal. If the correct voltage is now seen, this confirms excess resistance in the harness. If when testing the ECM connector, the voltage is still low, this confirms a fault to be within the ECM or ECM connector. Disconnect the harness connector and check for terminal tension and corrosion. If this is okay, then the excess resistance is within the ECM. A signal erratic or performance code will set when the signal voltage from the sensor is not within the calculated value expected by the ECM. When testing for either code, it may be necessary to wiggle the harness and tap the sensor or module while watching the meter display. With the red meter lead attached to battery positive and the black connected to signal terminal, turn the ignition on and watch the display. If the meter returned a reading of 0 or substantially less than battery voltage, there may be an open or excess resistance within the signal circuit. Move the black lead to the ECM while watching the meter. If the display now shows battery voltage, this confirms an open or excess resistance in the harness. However, if the correct voltage still isn't seen, then the open or resistance may be in the ECM connector or ECM. Turn the ignition off and inspect the connector for correct terminal tension and corrosion. If this is okay, the open or excess resistance must be within the ECM. Barometric pressure sensors play an important role for correct engine operation and reduced emissions. It's vital to understand how they work and how to test for a successful diagnosis. So, keep an eye out for signal voltage high and low training modules in this series. Thanks for watching. See you soon.